In this chapter, we shall study the phenomena of reflection and refraction of light using the straight-line propagation of light. These basic concepts will help us in the study of some of the optical phenomena in nature. We shall try to understand in this chapter the reflection of light by spherical mirrors and refraction of light and their application in real-life situations. Light is a form of electromagnetic radiation that is visible to the human eye. But more broadly, light includes other types of electromagnetic waves we can't see, like ultraviolet and infrared. Here are a few key things about light. Dual nature: light behaves both like a wave and a particle. As a wave, it has properties like wavelength and frequency. As a particle, it's made of photons, tiny packets of energy. Speed: in a vacuum, light travels at about 299,792 km per second, or approximately 186,282 miles per second. It's the fastest thing in the universe.
Colors: what we see as different colors are actually light waves with different wavelengths. Red has longer wavelengths, violet has shorter ones. Sources: natural sources include the sun, stars, and lightning. Artificial ones include light bulbs, lasers, and LEDs. Interacts with matter: light can be reflected, refracted, absorbed, scattered, or even bent by gravity, thanks to Einstein's theory of general relativity.
A highly polished surface, such as a mirror, reflects most of the light falling on it. Like bounced-back property of rubber ball. Light always follows the law of reflection, whether the reflection occurs off a curved surface or off a flat surface. The diagram below illustrates the law of reflection. In the diagram, the ray of light approaching the mirror is known as the incident ray, labeled I in the diagram. The ray of light that leaves the mirror is known as the reflected ray, labeled R in the diagram. At the point of incidence where the ray strikes the mirror, a line can be drawn perpendicular to the surface of the mirror. This line is known as a normal line, labeled N in the diagram. The normal line divides the angle between the incident ray and the reflected ray into two equal angles. The angle between the incident ray and the normal is known as the angle of incidence. The angle between the reflected ray and the normal is known as the angle of reflection. These two angles are labeled with the Greek letter theta accompanied by a subscript. Red is theta I4 angle of incidence and theta R4 angle of reflection. The law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal to the angle of reflection.
The law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal to the angle of reflection. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane.
What is light? Light is wave. Light consists of and nature. Speed of light in space is Wavelength of color is more has less. According to light travels to space in the form of electromagnetic wave. The angle between incident ray and normal is The angle between reflected ray and normal is Bouncing back property of light is Light causes the sensation of Light causes the sensation of